Hi guys, and welcome back. So, I think these review sessions are pretty much going to be the same for the rest of this whole online learning thing, for the rest of the school year at this point. Unfortunately, now there's really not a lot of opportunity to do any sort of fun reviews, so we just kind of gotta go through these presentations. I know they do help a lot of you, so maybe this will be like, you know, a good thing or a blessing in disguise. I think you guys have seen a lot by this point that we've got these three sections to talk about for your check 11.1, 11.2, 11.4, all the area stuff. All right, so let's just kind of jump right in. Area of a rhombus. It's really just, the whole thing is really just knowing the formulas for the areas of the different figures. So the area of a rhombus is half of the product of the diagonals. And we have expressions this time to represent both of those diagonals because it says D1, D2. So that's how you know it's the whole thing. So we're just going to go ahead and plug them right in. So half of x plus 4 and 2y minus 4. All right, so we do have to simplify this. Binomial times binomial, you got to FOIL it out. So I'm going to do that first and then distribute the half in. So we have 2xy minus 4x plus 8y minus 16. There's no like terms, so we got to leave this as is. Forgot to stick that half on the outside. And then again, we're just going to distribute in. So this is xy minus 2x plus 4y minus 8. And because you don't know anything about the actual numeric value for the area or anything about x and y, you just kind of got to leave it. Meter squared, don't forget your units. I will be looking for that on the check. And that's it for this problem. Okay. So find the area of a regular hexagon with radius 20. I think I might have done something like this in the lesson video for when we did area of regular polygons, where it helps me to actually draw it out. I don't know if it might help you. So when we talk about a radius in a polygon, it's the distance from a center, which I just drew in, to any of the vertices of the figure. So like that, for example, would be a radius. If that's 20, we know by definition of radius, it's the same thing for a circle, that it's the same no matter what. So any line that you draw from the center to any vertex is going to be the same. So like if I finish drawing this triangle right here, this line is also going to be 20. This angle up here, I think you guys might remember that formula, 360 divided by however many sides there are. So 6, since it's a hexagon, that gets us 60. So this angle down there is 60 degrees. All right? Since now we have an isosceles triangle, that means these two sides, angles down here are also congruent. So they're also going to be 60 and 60. And now we know that this triangle is equilateral, which means this is the other side of the triangle is also 20. Okay? So the perimeter, the whole reason why we did all that is because that's going to help us find the perimeter. We have one side is 20. We know it's regular, so all 6 sides are going to be the same. So 20 times 6 is 120 units for the perimeter. But we still also need the apothem, because again, remember the area of regular polygons in general is 1/2 times the apothem times the perimeter. So that would be something like that. And I'm going to redraw this. Let's make it a little bigger right here. So we have 20, 20, 20, 60, 60, 60. This is the apothem. And we know the apothem is perpendicular to the base of the figure. So if this angle is 60 and this angle is a right angle, that means this angle right here is 30. So there's a couple ways you could think about it. This 20 down here splits evenly into 10 and 10. That helps us get our short leg. Or we could also use the hypotenuse of this half of the triangle. It's 20. 30, 60, 90 rules. Cut that in half. It gets us the 10 anyway. And then the apothem, again, following the 30, 60, 90 rules, is 10 root 3. So I'm going to write that down. The apothem is 10 root 3. And then we're going to plug all that in. So the area is 1/2 of 10 root 3 times 120. So half of 10 is 5. So 5 times 120 is 600. So the exact answer for the area would be 600 root 3 units squared, because we don't have units for any of this. That's the exact answer, like I said. If the question asked you to round, you could just stick that in the calculator. Make sure to read carefully in terms of rounding directions or leaving exact answers. And in general, because I've gotten a bunch of questions about this still, I would say leave all answers in exact form, or leave answers exact as much as you can throughout the problem, and then round off at the very end. All right? As I think you might have seen in the last video, so there's sometimes where rounding off early might not be that detrimental, but I would still say if you can, keep exact answers until, if you're asked to round at the very end. Okay? Cool. All right. So, find the area of the figure. This is a composite figure. All right? So there are a whole bunch of ways that you could split this figure up into 2 figures. All right? It looks like we're going to have some kind of trapezoid thing down here and some kind of rectangle square type thing somewhere on this side. All right? What I'm noticing, or what I'm going to do, is I'm going to split this vertically down this way. All right? Thus creating a right angle down here. You could absolutely create a rectangle by splitting it this way and doing this part with this whole base. Doesn't really matter. At the very end of all this, you're still going to excuse me. Oh, excuse me. You're still going to combine the 2 and get the full area. All right? So we have this height is 10, and this base, or the width, the length and the width, are 10 and 5. So the area of my rectangle on the right is 10 times 5, which is 50 inches squared. All right? Now what about this trapezoid? All right? We have our 2 bases, 7 and 15. Well, actually, oh no, the 15 is the whole thing. Rewind. 15 is the whole thing. So if we're just talking about this trapezoid that I'm highlighting in black, and 15 is talking about the entire base, what's the base of the trapezoid? Well, we know this part is 5 because it came from the rectangle. So the rest of it is 10. So that's one of the bases that we're going to be using. All right? And in terms of the height right here, it's the same thing. We know this piece is 10 over here. Some of it is 6. So the rest of it is the difference. So the height is going to be 4. So the area of the trapezoid, pretend that's a trapezoid, is, if you remember the formula, it's half of the sum of the bases times the height. So half of 7 plus 10 times 4. So that is 34. So again, the area of the whole figure is just the sum of 50 and 34, which is 84 inches squared. And like I said, you should get the exact same thing if you had split it this way. Then it would just be some different measurements for each of the pieces of the whole figure. Okay? All right. So, area of the parallelogram. All right? If you guys remember, the formula for the area of a parallelogram is base times height, same as a rectangle. Okay? So, when we talk about height, it has to be perpendicular. All right? We know 5.5 is going to be our base, but we have to drop our perpendicular height down and do some stuff in order to figure it out. I hope you guys can kind of tell where this is going. If, kind of like with a couple problems ago, if this is a right angle and this angle right here is 60, this one is 30, so we're going to end up using 30, 60, 90 rules all over again with the hypotenuse of 4. So we cut that in half to get our short leg, which is down here. It's 2. And then 2 times root 3 is our long, is our long leg, and that's the height. So the area is 5.5 times 2 root 3, which is 11 root 3 meters squared. And again, exact answers unless specified otherwise. If it tells you to round, plug it in your calculator and then round. Okay? All right. Find SA, this length, if SP is 3, EA is 4, and EH is 2. Figure not drawn to scale. Okay? So we have SP is 3, EA is 4, and this EH is 2. All right? I think one thing that I had forgotten to put in this picture when I made this presentation was a couple little right angles right here. All right? That's a big help. All right? Having those right angle symbols there, because then you know that they're heights, and then you're able to use some pieces to figure out the area of the triangle. Specifically, SP and EA. All right? SP is perpendicular to EA, which means they are a respective base and height. So the area is 1/2 times SP, which is 3, times EA, which is 4. So the area of the whole triangle is 6. And the whole reason for doing all of this is because how are you going to figure out SA? Well, if you have a different height, you have a different base. But we're still talking about the area of the triangle. Like 6 is still the area of the triangle no matter what, even if your base and your height are different. So you can use the area formula all over again with all of these new numbers. The area is still going to be 6, and that's still going to be equal to 1/2 times the base, which is SA, times our height, which is now 2. And then you can solve that for B or for SA. And it's super easy in this case because the 1/2 and the 2 are just going to cancel each other out. And you're left with SA has a length of 6 units. There you go. All right. I think this is the last one. Finding the area of a triangle. So we just saw the formula for the area of a triangle is half base times height. I think a lot of you guys are thinking, okay, maybe we could drop a perpendicular height like this. All right? That's definitely what I was thinking too when I first came across this problem. The issue with that is the fact that this triangle is not isosceles. 12 and 18, so that means this opposite side is not going to be split evenly, and neither is the 150. You can't just divide it in half. What is 150 divided by 2? 75? You can't divide it in half like that. You know, even if you were able to, there's no rules that we know about for triangles involving a 75-degree angle, except for trig. You know, we could do trig. But again, because of this, the fact that they're not congruent, you can't split the 150 up in half. We don't know how it's going to split. So how are we going to figure this out? Where's our height? Well, if this is our base, I think there were problems like this in whatever section that was, 11.1 maybe. You can extend the base a little bit and drop your height this way. That creates your right angle. It's still the 18 that's going to end up being the base of our triangle since that's the flat part. And then it's just a matter of finding our height. But how do we do that when we don't know anything else about the triangle besides this right angle and the 12? Well, it's this 150 right here. If we extended the base a little bit, now this is a perfectly straight line, which means the 150 and the other side are supplementary. So this is 30, and here we go again. We have another 30, 60, 90 triangle. All right? So opposite the 30 is right here. 12 is still our hypotenuse, so half of 12 is the short leg, which is 6, and the long leg is 6 root 3. This one's also not drawn to scale. All right? But 6 is actually our height this time. We didn't even need to take that extra step to figure out the long leg because the height that we're actually using is the 6. So the area is 1/2 of 18 times 6, which is 54 units squared. All right? And that's your entire review. All right? I keep saying this every time. You guys know where to find me if you have any questions, and good luck on your check. Talk to you guys soon.